Hi, I'm James Mahoney. This video is designed to supplement an in-person class. Okay, let's look at some common ways to structure code in Unity projects, or coding patterns. The strength of Unity is the nice modular structure. The component-based system is really powerful. There is a scene hierarchy, which is composed of game objects. Game objects have modular units called components. Some components are part of Unity, like transforms, renderers, and things like that. But you can also create your own components by creating new classes that derive from mono behavior. This might look a little daunting at first, but it's useful for debugging timing issues of when things are getting done. So this loop is the game loop, and it runs at frame rate. Initializations, physics, game logic, rendering, etc. in this sequence really fast. And these are the most commonly used methods here. Start and update are the two default methods when you create a new script and a new component in Unity. These others might be useful to use as well, depending on what issues you're dealing with. And I've gone over these already before, but briefly, awake can be used to run code before all the other scripts run. And start is when you put most of your initializations, but sometimes you need to do something before that. Fixed update can be used in some cases when working with the physics engine and like physical simulations and things like that. And then late update can stop some things from jittering sometimes. This is an extracted list of the most commonly used methods for custom code, and they get executed in this order. You should be, by now, very familiar with the simplest and most common approach to wiring things up in Unity using the drag and drop pattern. Components expose parameters that get populated in the editor to affect or react to other elements, and that's where you're creating all of your dependencies. It's common to populate these parameter hooks with elements from your scene hierarchy. Public variables will be exposed in the editor as input fields, and private variables can also be exposed by using the modifier serialize field before the declaration. And here's an example of creating an array. I don't know about you, but I think this is pretty cool. So ask yourself, what are the advantages of this approach? Well, it's super fast, really easy, and great for quickly building prototypes. It's designer friendly. It's easy enough to understand for small projects. And these are all great things. But you should also ask yourself, what are the problems with this approach? It suffers from what's sometimes called the Metcalfe networking effect, meaning basically it just doesn't scale well. Large projects become very unwieldy. There are some solutions to this, and many are beyond the scope of what we can do here in this class. I can't point to one solution that everyone agrees is the best way to avoid the problem. Many developers are quite exuberant advocates of one way or another, and these battles ensue online. With drag and drop, sometimes changes or refactoring your code will require you to repopulate all the input fields. And if there's a lot of these, it might be hundreds, it's really a problem. It just doesn't scale well. So, and lots of dependencies mean that it's less modular, and it's difficult just to make any kind of changes and for anyone else to understand, and it's more difficult for testing. I'm sure you've learned this in your other core programming classes. Limiting public global variables is just good programming. With experience, everyone eventually learns that object interdependencies will make your code brittle, hard to extend or modify without breaking something. So you keep your dependencies clear and as simple as possible. No spaghetti code. At the risk of oversimplifying the problem, this is an abstraction of how I conceptualize it. It's that lower nodes have access to data passed down from the nodes above as parameters. Nodes often use just a subset of data from the more general classes above. And methods from above invoke the methods in classes that are below. You can use inheritance and class structure to impose order and create branches. For example, a poodle class inherits from the dog class, which inherits from an animal class. This is all very familiar to you, I'm sure. Which bits of code can access what data and what methods does each node have access to? This takes a lot of planning, and it's often not this clean in my experience. But you can't just sit down and start writing code. You need to have a plan. Goal is to avoid cross-pollination as much as possible, to avoid random dependencies. And this is really actually kind of difficult. Why? Because it makes the code less modular and more brittle and harder to understand and difficult to modify and debug if you have these cross-pollinations. Avoid accessing variables or methods on a different branch if you can, because that is what's making your code less modular. In conjunction with the desire to keep the code hierarchy clean, there's this common approach known as the MVC, or the Model View Controller paradigm. On one end is the user, and at the other is your backend database. And between them is the MVC. And the model, which is the current state of things, updated from the controller, it's the data you're dealing with. And view is sort of like the front end presenting the state of things to the user. And the controller facilitates the interaction between the view and the model, causing each to change. I think it's a little difficult to follow this approach in Unity exactly, but it's still a useful way to think about your code and your organization. In Unity, things are a little bit tricky because Unity itself offers a scene hierarchy and class inheritance that you need to work within. And it's very easy to generate spaghetti code with brittle dependencies. There are several approaches that people use to solve the complexity problem. There's the flyweight design pattern, the singleton design pattern, dependency injection, and there's others. So this would be my recommendation. For small projects like an in-class sprint or many of the projects you might be doing in this class, drag and drop is actually fine. It's really not a problem. You're just building a quick prototype and you're not working typically in big teams. Singletons with scriptable objects is the sweet spot, I think. A singleton is a single instance of a class. Dependency injection is used to maintain and update all the dependencies. And this is maybe good for really large or long-term projects, a lot of different people working on it, and then it might make sense. We're not going to get into that in this class. So here's the idea. Use scriptable objects, sometimes as a singleton, to hold your data. Think of these as modular data chunks, character data, scene data, etc. Scriptable objects are your magic wand for writing good code in Unity. And then you will want to create a few singleton manager classes. A singleton is a class that has been instanced only once, as I said, and it can never be instantiated again, unlike most classes in object-oriented programming. And the goal is to keep the dependencies between managers to a minimum. Maybe structure them as hierarchical, but plan clean dependencies as best as you can. Maybe it's helpful to think of your classes structured like this, with a section for data of various types and a set of methods. Imagine you've created an empty game object, a component on it called, NPC manager or scene manager or some other kind of manager. For all, in this case, might be for all of your NPC code. So it's a class. In this case, it would be class A in this example. And ideally, the methods only operate on the data that's in that class. And this keeps things super clean and dependencies more clear. And your data comes in lots of different varieties. There's serialized input, is the drag and drop stuff that you're already familiar with. And scriptable objects can be exposed in the editor. We'll get to that in a minute. These things can make your code more accessible to artists and designers. And some care is given to what things in your class might best be controlled by the designers on your team. Class A and Class B share a scriptable object data module. It's just one thing. It's one object. It's the same object that both can access. They each can invoke each other's public methods, of course. And remembering that these are typically components on game objects, and sometimes they're singletons. Avoid cross-pollination, where methods are directly interacting with data from another class without using a shared scriptable object or by invoking a method in the other class, as much as you can. Because that's how things become unmanageable and brittle and less modular. In summary, scriptable objects are very useful for organizing your code and data. They're not game objects. However, they will not persist between sessions. For example, if you're trying to keep track of what level a player is on, between sessions, you have to use another method. There's something called player prefs, or you use an actual database or a data file, an external data file, something like that for that in that case. Okay, let's look at scriptable objects. This script will set up a new data type with the name main data, and it will expose this in the Unity editor to allow you to create an instance of this data type. And then you can create one of these using assets create, and I'll show you this in a minute. Create instances of these data types to instantiate your data structure. And oftentimes you're going to want these to be singletons, but not always. Then with drag and drop, you can allocate which classes, which components get access to which data modules. New classes, components, can get the data block passed in with serialized parameters and then access the data directly in fairly obvious ways. You can get pretty fancy with this stuff if you need to. This is a real-world example from a personal project I was working on. And I know it's ridiculous that when I'm on vacation, I like to write code in Unity. But anyway, here we have nested data modules. Note that part is not a scriptable object, right? It's a data type in another scriptable object. It's a data structure nested in a scriptable object, as you will have in your sprint. However, in order for this to be serialized, you have to add the line system.serializable up top, and then serialize the field as normal. And then you can see in the example that these nested data structures on the right here, here you have an array of these things defined right here as parts. Anyway, I hope this is clear. Let me just do a really quick live demo to show you how this looks and how it actually works in practice. It's a good idea to keep things organized by creating a folder for your scriptable objects. Call it data. Now let's create a scriptable object. It starts just like any other C# script. In many cases, you will not need these methods, and so you can just delete them. By default, all your scripts will inherit from mono behavior. If you recall, scripts that are on game objects derive from mono behavior, but you can create your own classes. You can use all of the things you've learned in CS10 and other classes about object-oriented programming. You can use your own classes with whatever inheritance. You can create abstract classes or an interface class, all the normal stuff, and reference any public variables or methods just as you would expect. Yeah, here's an example of that from another project. But in this case, I'm going to use this as a way to structure my data in a neat, clean, modular way. So this has no methods. It's just data organized in a class. So accessed as mydata.numsn, for example. But this is where it gets really interesting. Let's make this a scriptable object. To do that, it will have to inherit from the scriptable object class. If I add this syntax, I can tell Unity to allow this to be instantiated as a scriptable object. It's best for clarity if the file name is the same as the class name. I'll show you how that works. If that compiles okay, you will see the script show up in the project panel. but I want the data structure to be a thing. If I go up to Assets, Create, at the top, all your scriptable object types are available, and you can instantiate one and give it any name you want. But it's of the type, whatever your class is called. It's like an int or a float, but instead it's typed as your class. When selected, the data fields are exposed in the inspector. And you, or an artist or designer on your team, for example, can fill this in and change these things as desired. To use this, create a slot for a variable of this type and serialize it. For example, let's use this singleton manager class. Your methods in this class can now access this data. You can read or you can write. And when you run it, the object will retain the values. It's amazing, right? Some things to consider when coding in Unity. The difference between const and static variables is important to understand. A const will be optimized by the compiler, sort of pulled out and retained, whereas a static will behave similarly, but it becomes part of the class. Although there might be several instances of that class, there will remain only one of these variables, marked as static. It can be a variable or a method. A good way to think of it is, as if it was stored in the class definition, rather than in the instance or any instance of that class. All right, so that's enough to get started. We'll go over more of this in class, and we'll talk a little bit more about it. But that should be a good way to get started. Hopefully you will learn to love scriptable objects.